Sure, I'd be happy to talk about aquaponics. Aquaponics is a sustainable method of agriculture that combines aquaculture, raising aquatic animals, with hydroponics, growing plants in water. In an aquaponic system, fish or other aquatic animals are kept in a tank, and their waste provides nutrients for plants that are grown hydroponically in a separate grow bed. The plants, in turn, filter the water and remove harmful toxins that can build up in the fish tank. The benefits of aquaponics are numerous. For one, it is a highly efficient use of resources, as the system recirculates water and nutrients, minimizing waste. Additionally, the plants and fish in the system can be grown in a variety of settings, including urban areas where traditional agriculture may not be possible. Aquaponics is also a sustainable method of food production, as it does not rely on synthetic fertilizers or pesticides. Some of the most commonly grown plants in aquaponics systems include leafy greens, herbs, and strawberries. Fish species that are commonly used in aquaponics include tilapia, catfish, and trout. Overall, aquaponics is an exciting and innovative approach to sustainable agriculture that has the potential to address many of the environmental and food security challenges we face today. Breeding trout in aquaponics requires a few key considerations. Here are the basic steps. Choose the right trout species. Rainbow trout and brook trout are two of the most commonly used species in aquaponics. It is important to choose a species that is suitable for the temperature and water conditions of your aquaponics system. Create the right environment. Trout require specific water temperature, pH, and dissolved oxygen levels for successful breeding. In general, trout prefer water temperatures between 10 to 18 degrees Celsius, 50 to 64 degrees Fahrenheit, and a pH between 6.5 to 7.5. Dissolved oxygen levels should be at least 6 to 7 parts per million. Provide spawning areas. Trout typically spawn in areas with a gravel bottom, where females can lay their eggs and males can fertilize them. Create spawning areas in your aquaponics system by adding a layer of gravel or other suitable substrate. Feed and monitor the fish. It is important to provide the trout with a balanced diet that meets their nutritional needs. Monitor the water quality regularly and make any necessary adjustments to ensure optimal conditions for breeding. Collect and incubate the eggs. Once the trout have spawned, carefully collect the eggs and transfer them to a separate tank or container for incubation. Keep the eggs at a consistent temperature and monitor them closely until they hatch. Rear the fry. Once the trout eggs have hatched, rear the fry in a separate tank until they are large enough to be introduced to the main aquaponics system. Breeding trout in aquaponics can be challenging, but with the right knowledge and careful management, it is possible to produce a sustainable source of protein and nutrients for your system. Breeding tilapia in aquaponics is a relatively straightforward process. Here are the basic steps. Choose the right tilapia species. Tilapia are a group of fish species that are well suited to aquaponics. The most commonly used species in aquaponics are Nile tilapia, Oreochromes niloticus, and Mozambique tilapia, Oreochromes mozambicus. Choose a species that is suitable for the temperature and water conditions of your aquaponics system. Create the right environment. Tilapia require warm water temperatures, between 25 to 30 degrees Celsius or 77 to 86 degrees Fahrenheit, and a pH between 7 to 8.5 for successful breeding. Provide plenty of hiding places, such as PVC pipes or rocks, for the tilapia to lay their eggs and protect their fry. Feed and monitor the fish. Tilapia are omnivorous and require a balanced diet that meets their nutritional needs. Monitor the water quality regularly and make any necessary adjustments to ensure optimal conditions for breeding. Separate males and females. Tilapia are sexually dimorphic, meaning that males and females have distinct physical differences. To encourage breeding, separate males and females into different tanks or sections of the aquaponics system. Stimulate breeding behavior. Tilapia can be stimulated to breed by increasing the photoperiod, the amount of time the fish are exposed to light each day, or by changing the water temperature. Gradually increase the photoperiod to 12 to 14 hours per day and raise the water temperature to the upper end of the preferred range. Collect and incubate the eggs. Once the tilapia have spawned, carefully collect the eggs and transfer them to a separate tank or container for incubation. Keep the eggs at a consistent temperature and monitor them closely until they hatch. Rear the fry. Once the tilapia eggs have hatched, rear the fry in a separate tank until they are large enough to be introduced to the main aquaponics system. Breeding tilapia in aquaponics can be a rewarding experience, as tilapia are prolific breeders and can provide a sustainable source of protein and nutrients for your system. How do you breed catfish in aquaponics? Breeding catfish in aquaponics requires some specific considerations. Here are the basic steps. Choose the right catfish species. Channel catfish, Ictalurus punctatus, and blue catfish, Ictalurus furcatus, are two of the most commonly used species in aquaponics. Choose a species that is suitable for the temperature and water conditions of your aquaponics system. Create the right environment. Catfish require specific water temperature, pH, and dissolved oxygen levels for successful breeding. In general, catfish prefer water temperatures between 24 to 30 degrees Celsius, 75 to 86 degrees Fahrenheit, and a pH between 6.5 to 7.5. Dissolved oxygen levels should be at least 6 to 7 parts per million. Provide spawning areas. Catfish typically spawn in areas with a flat or sloping bottom, where females can lay their eggs and males can fertilize them. Create spawning areas in your aquaponics system by adding PVC pipes or other suitable substrate. Feed and monitor the fish. Catfish are omnivorous and require a balanced diet that meets their nutritional needs. Monitor the water quality regularly and make any necessary adjustments to ensure optimal conditions for breeding. Separate males and females. To encourage breeding, separate males and females into different tanks or sections of the aquaponics system. Stimulate breeding behavior. Catfish can be stimulated to breed by increasing the water temperature or by changing the photoperiod. Gradually increase the water temperature to the upper end of the preferred range and increase the photoperiod to 12 to 14 hours per day. Collect and incubate the eggs. Once the catfish have spawned, carefully collect the eggs and transfer them to a separate tank or container for incubation. Keep the eggs at a consistent temperature and monitor them closely until they hatch. Rear the fry. Once the catfish eggs have hatched, rear the fry in a separate tank until they are large enough to be introduced to the main aquaponics system. Breeding catfish in aquaponics can be challenging, but with the right knowledge and careful management, it is possible to produce a sustainable source of protein and nutrients for your system. What kind of setup for trout would you suggest? When setting up an aquaponics system for trout, there are several factors to consider. Here are some suggestions for a suitable setup. Tank size and shape. Trout require plenty of space to swim and grow, so the tank should be at least 1,000 liters, 264 gallons, in volume. The tank should also be deep enough to allow the fish to swim vertically, with a depth of at least 60 to 75 centimeters, 24 to 30 inches. A rectangular or circular tank is generally preferred for trout. Water temperature and pH. Trout are cold water fish and prefer water temperatures between 10 to 18 degrees Celsius, 50 to 64 degrees Fahrenheit. Keep the water pH between 6.5 to 8.0. Use a heater to maintain a consistent water temperature within this range. Filtration system. A biofilter is essential for removing harmful toxins and waste products from the water. A common approach is to use a flood and drain gravel bed filter, in which water is pumped into a bed of gravel, and then drained back into the tank. The gravel provides a surface area for beneficial bacteria to grow, which convert the fish waste into nitrate, a form of nitrogen that can be used as fertilizer for plants. Lighting. Trout require a natural photoperiod, the amount of time the fish are exposed to light each day, to maintain a healthy circadian rhythm. Provide a minimum of 8 hours of light per day and use a timer to simulate a natural day/night cycle. Feeding. Trout are carnivorous and require a high-protein diet. Feed them a high-quality fish food that is specifically formulated for trout. Plants. Adding plants to your aquaponics system can help to improve water quality by absorbing excess nutrients and provide additional oxygen to the water. Choose plants that can tolerate the cold water temperature and that do not require high pH levels. Oxygenation. Trout require high levels of dissolved oxygen in the water to thrive. Use an air pump and diffuser to add oxygen to the water and maintain a healthy environment for the fish. By setting up an aquaponics system that meets these requirements, you can create a sustainable and efficient way to grow trout while simultaneously cultivating plants in a closed-loop ecosystem. The tank should also be deep enough to allow the fish to swim vertically, with a depth of at least 60 to 75 centimeters, 24 to 30 inches. A rectangular or circular tank is generally preferred for trout. I would think they would like anything over 2 feet depth, 3 to 4 feet wide, 10 to 20 feet long. You are correct that a depth of 2 feet or more would be suitable for trout, and a tank that is 3 to 4 feet wide and 10 to 20 feet long would provide adequate swimming space. Here's how you can calculate the volume of such a tank in liters. Assuming a tank that is 2.5 feet deep, 75 centimeters, 3.5 feet wide, 105 centimeters, and 15 feet long, 450 centimeters, the volume can be calculated as volume equals length x width x depth. Volume equals 450 centimeters by 105 centimeters by 75 centimeters. Volume equals 3,543,750 cubic centimeters. To convert cubic centimeters to liters, divide the volume by 1,000. Volume, in liters, equals 3,543,750, 1,000 volume, in liters, equals 3,543.75 liters. Therefore, a rectangular tank that is 2.5 feet deep, 3.5 feet wide, and 15 feet long would have a volume of approximately 3,543.75 liters. One way to keep a good temp is put the tank in the ground for thermal dynamics. Yes, placing the tank in the ground can help to regulate the water temperature in an aquaponics system. The earth provides a natural insulation, which can help to keep the water temperature stable and prevent fluctuations that could be harmful to the fish. In addition, if you live in a region with cold winters, burying the tank partially in the ground can help to protect it from freezing. The earth can help to maintain a consistent temperature around the tank, which can prevent the water from freezing or becoming too cold for the fish. However, it is important to ensure that the tank is properly sealed to prevent groundwater contamination, and that there is adequate drainage to prevent flooding in the event of heavy rain. How many trout could we keep in that size of tank of approximately 3,543.75 liters? The number of trout that can be kept in a tank of 3,543.75 liters will depend on several factors, including the size of the fish, the rate of water exchange, and the amount of oxygenation provided. However, as a general rule of thumb, a stocking density of 20 to 30 kilograms per cubic meter can be used for trout in a recirculating aquaponics system. Assuming a stocking density of 25 kilograms per cubic meter, the number of trout that can be kept in a 3,543.75 liter tank can be calculated as stocking density equals 25 kilograms per cubic meter. Volume of tank equals 3,543.75 liters or 3.54 cubic meters. Number of trout equals stocking density x volume of tank. Number of trout equals 25 kilograms per cubic meter by 3.54 cubic meters. Number of trout equals 88.5. Therefore, a tank with a volume of approximately 3,543.75 liters could support around 88 to 89 trout, rounded down to the nearest whole number. It is important to monitor the water quality and oxygen levels closely to ensure that the fish are healthy and not overstocked. Yes, it is possible to incorporate a stream or flowing water into an aquaponics system. However, this type of system can be more complex and may require additional equipment and maintenance. In a stream aquaponics system, the fish tank is connected to a series of channels or pipes that allow water to flow continuously through the system. The water flows from the fish tank through a filter or biofilter, where waste products from the fish are broken down by beneficial bacteria. One advantage of a stream aquaponics system is that the flowing water can provide additional oxygenation and aeration for the fish, which can help to improve their overall health and growth. However, it is important to ensure that the water flow rate is not too fast, as this can stress the fish and disrupt the system's balance. Another consideration is the design of the stream or channels, which should be sloped to allow for proper water flow and prevent stagnant areas where waste and debris can accumulate. The stream should also be properly screened to prevent fish from escaping and predators from entering the system. Overall, a stream aquaponics system can be a beautiful and functional way to grow fish and plants, but it requires careful planning, monitoring, and maintenance to ensure success. Now we are going to make a hydroponic system, 2 layers, 3 feet wide, 10 feet long, 6 in deep. How much water would be in one of them? Volume equals length x width x depth. Assuming a layer that is 3 feet wide, 10 feet long, and 6 inches deep, we first need to convert the depth measurement from inches to feet. Depth equals 6 inches, 12 inches per foot. Depth equals 0.5 feet. Then we can calculate the volume of the layer as volume equals length x width x depth. Volume equals 10 feet by 3 feet by half a foot. Volume equals 15 cubic feet. To convert cubic feet to gallons, we can multiply the volume by 7.48, which is the number of gallons in 1 cubic foot. Volume, in gallons, equals 15 cubic feet x 7.48 gallons per cubic foot. Volume, in gallons, equals 112.2 gallons. Therefore, to fill one layer of your hydroponic system that is 3 feet wide, 10 feet long, and 6 inches deep, you would need approximately 112 gallons of water. Let me know how you felt about this idea. I was interested in aquaponics from Apuaponics Revolution.